right, pre-algebra. We are moving on in chapter 13 to talk about length and area of similar regions today. So hopefully you have your books open to 13.4, page 557. And we are going to first look at two similar triangles, okay? And we have two similar triangles. Remember the symbol for similarity is that one wavy sign, okay? And we have triangle ABC and triangle XYZ, and those triangles are proportional, okay? Triangle ABC has sides of 4, 5, and 6, and XYZ has sides of 8, 10, and 12. Since every side of triangle XYZ is twice the length of its corresponding side in triangle ABC, we say their scale factor is 2. So every side of triangle XYZ is twice the length of its corresponding side in triangle ABC. The scale factor is 2. Okay? The perimeters of these triangles, take a look at them really quick. Perimeter of the smaller triangle, 4 plus 5 plus 6 would be 15 units. And I'm just going to say P1. I'm going to call this one 1 and this 2. The perimeter of triangle 1 is 15. And the perimeter of triangle 2, 8 plus 10 plus 12, is 30. So what do you notice about their perimeters? What do you notice about their perimeters? Okay. The perimeters have the same scale factor, okay? They have the same scale factor. So perimeters are in the same ratio as the corresponding sides of their triangles. So ratios of the perimeters of similar triangles, or excuse me, similar polygons, is equal to the ratio of corresponding sides. And we can use this principle to help us solve for unknowns. So example number 1 says the corresponding sides of two triangles are 16 inches and 12 inches. The perimeter of the first is 55 inches. Find the perimeter of the second, okay? So the side of the first is 16 inches, and the corresponding side of that one, so side 2, is 12 inches. The perimeter of the first, so P1, is 55 inches, and P2 is unknown. Okay, we don't know what it is. Literally says find P2. So we're going to call that one X. Okay, so set up your ratios. 16 is to 12 as 55 is to X. Notice that's side 1 over side 2 is equal to P1 over P2. Now we're going to use cross multiplication to solve. Before I do that though, I'm just going to make my life a little bit easier and reduce the 16 over 12 to 4 over 3. You don't have to. You're still going to get the same answer if you don't. So we have 4 times X is equal to 55 times 3, and I'm going to go sideways. I know I always tell you guys not to go sideways, but I'm running out of room. 4 times X is equal to 165. X is equal to 41.25 inches. So that is the perimeter of the smaller triangle. All right, example number 2. Perimeters of two similar hexagons are 20 feet and 180 feet. So we have P1 is 20 feet, P2 is 180 feet. The smaller has one side of 2 feet. So side 1 is 2 feet. Find the corresponding side of the larger. So side 2 is what we don't know. Okay, that is our unknown. Go ahead and set up your ratios. Do side 1 over side 2 is equal to P1 over P2. So 2 over X is equal to P1, which is 20, over P2, which is 180. Go ahead and simplify, reduce that fraction, make your life easier. Whoops. 2 over X is equal to 1 over 9. That's 20 over 180. So we have 2 times 9, which is 18, is equal to 1 times x, okay? So the side that we were looking for, side 2 of the larger, is 18. And remember, units matter, so 18 feet. Skill check number 1. We have side 1 of 10, perimeter 1 of 47, side 2 of 7, and what is P2? All right, find the perimeter. Round answers to the nearest tenth if we need to. So again, side 1 over side 2 is equal to perimeter 1 over perimeter 2. So plug in what we have. 10 over 17. Sorry, 10 over 7, not 17. 10 over 7 is equal to 47 over P2, which is x. And, sorry, I forgot to grab my calculator before I sat down to work on these with you. So we get 10x is equal to 47 times 7, 329. Divide both sides by 10. And we get x is equal to 32.9. We don't even have to round because that's what it is. We're not given any units, so I'm just going to go ahead and write units. There's our perimeter of our second figure. Number 3, side 1 is 5, perimeter 1 is 12, perimeter 2 is 70. So what are we missing? We're missing side 2. We don't know what side 2 is. So side 1 over side 2 is equal to perimeter 1 over perimeter 2. So 5 over side 2, or x, you can use whatever you want, over perimeter 1, 12 over 70. Use cross multiplication. 350 is equal to 12 times S2, or if you just want to plug in x, whatever you want to plug in is fine. Divide both sides by 12. 350 divided by 12, 29.16666. That just goes on forever. So approximately, because we're rounding to tenths, 29 and 2 tenths. We're not given units for this one, so we'll just write units, and there's our answer. Go ahead, practice on number 2 and number 4. The answer that you should get for number 2 is 20.6 units, and number 4 is 14 and 6 tenths units. Now, let's talk about areas, okay? We just showed that the perimeters of similar polygons have the same scale factor as corresponding sides. What about area? Okay, so here we have 2 rectangles. Okay, the area of our smaller rectangle, base times height, would be 24. And the area of our larger rectangle would be 4a times 6a, which would be 24a squared. We're just kind of adding on this this a unit here, okay? So we know 24 and 24a squared. So, excuse me, we end up with 4a over 4. Here's a ratio of corresponding sides, okay? Corresponding sides. What is the ratio of our areas? The ratio of our areas is 24a squared over 24, this corresponding side, and this is the ratio of the areas, okay? So a, and over here we have a squared. Those obviously are not equal to one another. So the ratio of corresponding sides to the ratio of the area is not equal, like the ratio of corresponding sides to the perimeters of similar figures is equal, all right? But what do you notice? We have a and we have a squared. A squared. So the areas are in the same ratio as the square of the scale factor instead. And this property is true of any pair of similar polygons, not just rectangles. Okay? So ratio of the areas of similar polygons, the ratio of the areas of similar polygons is equal to the ratio of the squares of the corresponding sides. And I should have put another blank in there. There we go. Of the corresponding sides. So example number 3. The first of two regular polygons has a side of 4 centimeters. The second has a side of 3 centimeters. What is the ratio of their areas? So we have side 1 and side 2. Okay? Side 1 is 4. Side 2 is 3. And our principle of the areas says that the ratio of the areas is equal to the ratio of the squares of the corresponding sides. So if we want to find out what the ratio of their areas are, we just need to square the sides. Now, when we are squaring a ratio or a fraction, we raise both the numerator and the denominator to that power. So 4 squared is 16, 3 squared is 9. So if the ratio of their sides, of their corresponding sides, is 4 to 3, then the ratio of their areas is 16 to 9. It's just their sides squared, their corresponding sides squared. Example number 4. The first of two similar polygons has a side of 3 centimeters and area of 10 centimeters squared. The corresponding side of the second is 5 centimeters. What is the area of the second? So S1 is equal to 3 centimeters. Area 1 is equal to 10 centimeters squared. Side 2 is equal to 5 centimeters. Area 2 is equal to, we don't know. So you could plug in a variable for that, a or x, okay? Or you could just use a2 as your variable, whatever you want to do. So what we're going to do with these is we are going to say area 1 over area 2 is equal to the square of the corresponding sides. This is what we're going to use over and over again. Plug in what we know. Area 1 is 10. Area 2, we don't know. I'm just going to keep that as area 2, is equal to side 1 is 3, side 2 is 5, squared. Okay? 10 over A2 is equal to 3 squared is 9, 5 squared is 25. Now I can use cross multiplication. Okay? So 250 is equal to 9A2. Divide both sides by 9, and we get A2 is approximately 27 and 8/10 centimeters squared, because we're talking about area. Example number 5. The areas of two similar pentagons are 400 millimeters squared and 100 millimeters squared. One side of the smaller is 9 millimeters. Find the length of the similar side of the larger. So, what do we have? We have S1 is equal to 9 millimeters, and area 1 is equal to 100 millimeters squared. How did I know that? Because we have 400 millimeters squared for one area, 100 millimeters squared for the other, and it tells us that the side of the smaller is 9 millimeters. So if the smaller one side is 9 millimeters, we are going to use the smaller area, okay? So side 1 is 9, area 1 is 100. Side 2 of the larger, we don't know what that is. Area 2 of the larger is 400 millimeters squared. Side 1 over side 2 squared is equal to area 1 over area 2. Okay? Plug everything that we have in. 9 over S2, we don't know what S2 is, squared is equal to A1 over A2. 100 over 400. 9 squared is 81 over S2, second side squared, is equal to 1 over 4, just going ahead and simplifying that. So then we have 4 times 81. 4 times 81 is 324, is equal to 1 times side 2 squared times 1, so that's just side 2 squared. How do I get side 2 by itself? I need to take the square root of both sides. Side 2 is equal to the square root of 324, 18 millimeters. And all done. Okay, skill check number 2. We are given side 1 of 6, area 1 of 30, side 2 of 7, which means we do not know area 2. Remember, A1 over A2 is equal to S1 over S2 squared. Plug in what we know. 30 over A2, we don't know, is equal to 6 over 7 squared. 30 over A2 is equal to 6 squared is 36 over 49. Okay. 30 times 49. I'm going sideways because I didn't give myself enough room. You know, I hate it when you guys do that though. Okay. 30 times 49 is 1,470 is equal to 36. A2. Divide everything by 36. And that is 40.83333. So we are going to round to the nearest tenth. 40.8, and we're not given a particular unit, so we're just going to say units squared. Units squared because this is the area. All right. Now, number 3, side 1 is 6, area 1 is 40, area 2 is 90, which means we don't know side 2. So side 1, 6 over side 2, we don't know, squared is equal to 40 over 90. So 36 over side 2 squared is equal to 4 over 9. 36 times 9, 324 is equal to 4 times side 2 squared. Divide both sides by 4. 81 is equal to side 2 squared. Take the square root of both sides, and side 2 is equal to 9. We are not given units, so it's 9 units. We're talking about the length of a side, so it's just 9 units. Practice with number 2 and number 4. The answer to number 2 is approximately 2.2 units squared because that is an area. And number 4 is 9.8 units, and it's just units, not units squared, because that is the length of a side.